Okay, so this is the June 2017 IAL paper. So again, I will be discussing the series question in this particular paper. Okay, question number 3. Show that r cube minus r minus 1 cube is 3r square minus 3r plus 1. How do you get this? Show that. So this is an identity. So to get this, you have to, you need to take one side and prove the other. Which side should we take? Which side is it easier to work with? Let's work with the left side. So when you work with the left side, we get r cube minus r minus 1 cube. Shall we expand? R cube minus r minus 1 cube is, either you could expand r minus 1 cube by using binomial expansion, or you could expand it manually. Okay, either go with the binomial expansion of r minus 1 cube, or we'll do a manual expansion. R cube minus, let's keep the r minus 1 and open the other bracket, the pair, second pair. So r into r is r square, r into minus 1 is minus r, minus 1 into 1 is r minus r, so minus 2r, right? Minus 1r minus 1r is minus 2r, minus 1 into minus 1 is plus 1. So then what do we get here? R cube minus, expand the bracket with r minus 1, keep the bracket because there's a minus mark in front. R into r square is r cube, r into minus 2r is minus 2r square, r into 1 is 1r, minus 1 into r square is minus r square, minus 1 into 2r is plus 2r, minus 1 into plus 1 is minus 1. Expand the bracket. So we get here r cube, open the bracket, minus r cube, minus into minus is plus 2r square, minus r, plus r square, minus 2r, plus 1. Can you see I'm reversing the change of every single number inside the bracket because I'm expanding with the minus sign. So what do I get here? R cube minus r cube can actually cancel out, right? R cube can minus r cube can actually cancel out. What's remaining? 2r square plus r square is 3r square. Minus r minus 2r is minus 3r and plus 1, which is the show that. Can you see that's a show that for part A? So we'll move on to part B, last part. Hence, prove by the method of differences that for n that when n is an element of positive integers, z plus is positive integers, summation of r square is equal to n plus 1, 2n plus 1 over 6. You have to prove this equation by using what? By using the method of differences. By using the method of differences, prove this equation. Okay, you may use summation of r is n plus 1 over 2 without proof. You are allowed to use this equation directly. Okay, so how do we get the method of, we have to use method of differences also and make r square the subject. So how do I create an r square here? You know, the only r square I can see here is the r square that I'm seeing in part A. So that is the r square that I have to subject to get this. Okay, and the method of differences, to whom do I use the method of differences? I don't have partial fractions or anything here, but you do see that there is a subtraction between two terms. Can you see? R cube minus r minus 1 cube. So this is where you go for the method of differences. So basically all you have to do for part B is take the summation of the part A answer. What do you mean by that? R cube minus r minus 1 cube. Take the summation of both the sides. 3r square minus 3r plus 1. Take the summation of both the sides. Are you with me? Okay. So then over here, this is equal to 3 times summation r square. This is open the bracket. Now over here, you can put the summation mark inside. Look at this. Okay, I took the summation of both the sides. And this is 3 times summation r square. This is minus 3 times summation r. Plus this is summation 1. Are you with me? We are trying to get the summation of whom? We are trying to prove the summation of r square. Okay, so I want this guy. This is the guy that I'm interested in. These guys, do we know summation of r? Yes, summation of r is given to you as what? n plus 1 over 2. Actually, there are results that you learned in F1, right? Summation of r is n over 2, n plus 1. And also there's another summation of 1 is n. So these are the two main rules that you need to use here. Okay, so let's go ahead with it. 3 times summation r minus 3 times summation of r is n over 2 n plus 1. Isn't it? You can directly use it. Plus summation of 1 will be n. And you see that I have got these answers. Now what's remaining? The only thing that's remaining here is to get the summation of r cube minus r minus 1 cube. Okay, shall we get it? So we'll get this when r equals 1. So for this side, I will go for the method of differences. Are you with me? I will get the method of differences for this side. So using r equals 1, what do I get? 1 cube minus 1 minus 1, 0 cube. Are you with me? This is when r is 1. When r is 2, what do I get? 2 cube minus 2 minus 1 is 1 cube. When r is 3, what do I get? 3 cube minus 3 minus 1 is 2 cube. When r is 4, what do I get? I think I don't need to go there. Do you see the cutting pattern? Can you see the cutting pattern? Which way does it cut? I think you can see it cuts diagonally, not this way, it cuts this way. Plus 1 cube minus 1 cube plus 2 cube minus 2 cube, the cutting pattern. So in the top, you can see you have one element remaining in the top right corner, which means there will be element remaining in the bottom left corner. So that is at the very end. When r is n. So when r is n, I will get n cube minus n minus 1 cube. Are you with me? So this cutting pattern should continue until the very end. So here at the top right, which means at the bottom left. So then when you take the summation of everything, what's remaining now? So you have remaining here minus 0 cube and this is plus n cube. Can you see what's remaining from this summation over here? This side minus 0 cube and plus n cube is remaining. On the other side, you have 3 times summation r square minus 3 times n over 2n plus 1 plus n. Are you all with me? And now what do we need to do? Make summation r square the subject. Make summation r square the subject. So n cube, I'll bring the plus 3n over 2n plus 1 here. Plus n comes as minus n and you are remaining with 3 times summation r square. I took these two terms to the other side. The minus term became plus, the plus term became minus. What's the next thing to do? I think you can see definitely what is common to all the three terms. N is common. Shall we take n out? When we take n out, what's remaining? N square plus 3 over 2n plus 1 minus 1 equals 3 times summation of r square. Are you with me? So now what's the next thing to do? The next best thing to do here is to go for the common denominator, which is 2. Go for the common denominator. So n times common denominator is 2. So over here, what happens? There's no 2 here, which means this becomes 2n square. This guy already has the 2, so we don't need to fix it. It's 3 times n plus 1. Minus here, there's no 2, which means this 1 multiplies with the 2. 3 times summation r square. So I could bring the 2 out here as n over 2. Are you okay with it? N over 2 inside the bracket. 2n square plus, open the bracket. 3 into n is 3n. 3 into 1 is 3. Minus 2 equals 3 times summation r square. Are you all with me? So n over 2, 2n square plus 3n. 3 minus 2 is 1. We can bring the 3 to the other side as a division. Can you see it? Sorry, minus 2, right? Minus 2, right? No, plus 3 minus 2 is plus 1. Plus 1. So the 3 will come to the other side as a division. N divided by 6. 2n square plus 3n plus 1 equals summation r square. I brought the 3 to the other side as a division. That's why it became a 6. Now I think this can be factorized, right? You can factorize from the cal. What do you get? Should be n plus 1, 2n plus 1. Is it? That is, we show that we get n plus 1, 2n plus 1. the factors in your cal will be -1 and -half, right? So you get n plus 1, 2n plus 1, which is the show that, and this is exactly what you are required to show. Is this clear? Okay.